Hi everyone and welcome to my channel. This video covers the topic of transformation of graphs. It's done in lower 6, Pure Maths Module 1, and this is my second video. So I'm going to call this part 2 on this, right? Going through my first video, you would see that I covered vertical translation and horizontal translation. And in this particular video, I'm going to cover vertical stretches and horizontal stretches. So I'll now begin with a vertical stretch. A vertical stretch simply means that I'm taking my curve, whatever curve I'm given, and I'm transforming it so that it stretches vertically, right? So say for example, my original curve was g of x, and I multiply some factor to my g of x function. It will now become a by g of x. So my original points being PQ will now become PAQ. So let me explain this better with some examples. So say g of x was x squared. We all know how the x-squared curve would go. And say now I change this to 2 by g of x. So now my a is 2. So this becomes 2 by x squared. So 2x squared. So let me look at the transformation of this original graph to this new graph. So my original graph would kind of look like this. Right? This line, the y-axis, would be the symmetrical line for it. So this is g of x is equal to x squared. Right? So I'll have many points here, 0, 0, 5, 25, etc. Right? Now, if I were to stretch this vertically by 2 units, that's because my E is now 2, this is my E, right? This curve now becomes this one. All my values, PQ, will now become P by EQ. So say the point, well, 0, 0 will become 0 by 2 by 0, which will still be 0, 0, right? So I'll still have this point here. The point 525 will become 5 by 2 by 25, so it'll become 550. So all my values here will then stretch upwards, even on this side here. So what will happen is that my curve will still maintain its symmetrical, the axis of symmetry being the y-axis. However, my curve will now narrow down a bit. It will come in more like this. So now I'll have, say, my value here. So here, I'll say here 550. This is still 0, 0. This could be some other value, and so on. So now this is now the 2 g of x curve, which is 2x squared. So this is what happens to a quadratic when we do a vertical stretch. Now let me go to another example on the vertical stretch. Example 2 now will go like this. Say my g of x were linear, x plus 3, and now I want to change it to say 4 by g of x. This becomes 4 by x plus 3, which becomes 4x plus 12. Sorry, 12. Right, so the x plus 3 line will just be a straight line, right? And it will go something like this. And this point here will be 0, 3, and so on, right? This point here would also be minus 3, 0. Now this line now, if I were to apply a factor of 4 here, because a is now 4, my points will now move from PQ to PAQ. So it will be minus 3, 0 will now become minus 3, 4 by 0, because it's now 4. 0, 3 will now become 0 and 4 by 3. So this will be minus 3, 0, and this one will be 0, 12. So these are my new points now. So let me go minus 3, 0 will be the same point around here. And 0, 12 also be probably somewhere up here. 0, 12. So now all I need to do now is connect. Take one straight line. Oh shoot, doesn't look so good there. Let's try it again. Trying to draw this freehand, right? Something like that. Good. And this now I'll label. Remember, label your points, label your axes, label your graph. Right. So now this now is the 4g of x function, which is 4x plus 12, and this one is the g of x function, which is x plus 3. So this, everybody, explains pretty clearly what happens with a vertical stretch when we use our linear curve. Right? A linear curve now is a straight line. It just simply shows us that it's stretching and it's moving upward. And all my values are kind of shifting a bit, right? But it's going to maintain it. The slope is going to be different, as we can see, right? Some points will remain the same, like this point here remain the same. However, all the other points changed, right? So now let me cover my third example on the vertical stretch. The first two examples are pretty simple. My third example now is a little more complicated. It's e to the x, and say I change this now, and it becomes 2j of x, it becomes 2 e to the x. Now this is what happens. This is my e to the x curve. Sorry, let me try this a little better. I have an asymptote here, right? This is my point 0, 1, y-axis, x-axis, 0, and the asymptote is here, right? The horizontal asymptote is here, right? The x-axis. Now what happens? I have many other points on this curve, but what happens with this particular curve, because it has a factor here of 2, and it's a vertical stretch, it means that the asymptote will remain like this, but it will just go higher up like that, right? So this point now will now become 0, 2. And I'll show you, because of this, 0, 1 will become 0 by 2 by 1, which will be 0, 2. Could confirm that there, right? So this is what happens with vertical stretches, right? It's very different from a vertical translation. A vertical translation simply means that I am shifting my curve from one particular position to another, and everything else is staying the same. The shape, the width, all those different things, the gradients. However, in this particular example, for stretches, we see that that's not really happening. Our curve is either coming in a bit or stretching out some more, right? And that clearly explains why we call it a stretch, right? Okay, so that has covered vertical stretches, my 3 examples for that. Now I want to go through some examples for horizontal stretches. Look at the little note I have on the side here for horizontal stretches. It says if I have g of x and it now becomes g of ax, right? So my a now goes into the function of g. My points pq will now become 1 on ap q, right? So this will correspond for all my points, right? Now, what also is missing here is that a little note it says the graph is a stretch. It's a stretch parallel to the x-axis by factor 1 on a. Right, so let me explain that by some examples. Example 1. Say g of x was the curve x plus 3, and say it now becomes g of 2x. That will become 2x plus 3, and that'll be that, right? So this is this, and this is that. So let me do my sketch. So this first one, g of x is equal to x plus 3, that'll be a line like this. Right. Here would be 0, 3. Here will be minus 3, 0. Right. Now, so PQ, they say will go to 1 on AP Q. Alright? So my point 0, 3 will now become a half of 0, 3, which will still be 0, 3. This one now minus 3, 0 will now become a half of minus 3, 0, which would be minus 3 on 2, 0. So I have 2 points here. So I could say this is my first point, 0, 3, minus 1.5, say that around here. Minus 3 on 2, 0. And my curve will go, my line will now be like this. Right, so I know it sounds a little complicated. Stretch parallel to the x-axis by the factor of this, right? Now what happened? Because my e is 2, the factor is a half. Because it's 1 on e, will be a half. So when they speak about the stretches parallel to the x-axis by that factor, what we're going to look at is the distance here. So say I want to distance from here to here, that will be 3 units, right? Well, minus 3, but we're going to 3, right? Now what has happened, because it's a factor of a half, that 3 units will now be multiplied by a half, and I will now get 1.5. So that is how this now becomes 1.5 here. This distance here is now 1.5. So the same thing goes for all these other distances here. If we measure this distance from here to here, from the original point to the y-axis, when we divide it by 2, because my e was 2 in the sum, we will get half of that new distance here, right? So that is what this section here means, right? So now let me move on to example 2. Example 2 goes like this. If g of x were this, x squared plus 2x minus 3, and say I want to do g of 2x. Again, my e here is 2, right? This now becomes 2x squared plus 2 by 2x minus 3, which really becomes 4x squared plus 4x minus 3, right? And this one becomes x minus 1, x plus 3, if I factorize, x is equal to 1, x is equal to minus 3. Right, so plotting, well not plotting, but sketching these two graphs, I will get something like this. I'll get this point here, it'll be like this, like that, and say it'll be like that. Oh boy, that doesn't look so great. Let me just fix it up a little bit. Let's move that in this one. Right, something like that. Right. So say now this will be the point 1, 0, and this will be the point minus 3, 0. Right. So this is the g of x cube. Right. Y x 0. Right. Now what will happen to this now? My points, so say minus 3, 0, will now become a half. Sorry, minus 3, 0 will now become a half of minus 3, 0, which will be minus 3 on 2, 0. 1, 0 will now become a half of 1, which is a half 0, right? So now plotting these points, now I'll get like say here and say here, right? Somewhere here, right? So what happens now? We can see, right? The distance between here and here, right? This is 1 unit here. And now this point now is a half 0. This point now is minus 2 on 3 on 2, sorry, 0, right? This now is half. Same for here. This whole distance from here to here was 3 units. And because I'm using a of 2, that means my factor will now be 1 on 2. This now becomes 1.5. So this is what they mean by a stretch parallel to the x-axis, right? Now moving on to example 3. So this just now as example 3, right? But this is really my question 1, my first official question doing a sketch based on all these lessons here, right? Everything here. Now, say I was asked to sketch this. This is a typical lower 6 pure maths question. We can see a couple things happen here. This is e to the x. We know that graph pretty well by now. This one now, this 2 in front of this, means that this is a vertical stretch, right? That's here. And this plus 3 here means it is a vertical translation, right? That's here. So let me go about the steps to get this. The first thing I need to do is start with the e to the x groove. So the first thing I'm starting with is the graph of e to the x. So that looks like this. Here, 0, 1. That's y is equal to e to the x. Now if I change this now to y is equal to 2e to the x, as I said, that's a vertical stretch. So that now becomes this point here. It just stretches upward like this. My asymptote is still this value at the x-axis, right? And then if I do a plus 3 now, that's a vertical translation, so I'm going to shift upwards. So it means that instead of 0, 2, 0, 2 is now going to be 0, 2. It's going to be 0, 2 plus 3, which is going to be 0, 5. So I'll just come up here. Point here is going to be 0, 5. Right? And since my asymptote now was 2 units away from this point of contact, this will still be 2 units away, so it'll be at y is 3. So then I'll draw a dotted line here, y is 3, and then I'll just loop like this, go up like that. So thanks everyone for watching. I hope you understand and please feel free to look at it again. Thanks guys.